Hey everybody, these are word problems for growth and decay that are modeled by exponential functions. It would probably be a good idea to pause the video right here and go ahead and copy all this down. All right, so the first one is for just simple growth and decay. For all of these problems, the R is the rate. And so the rate is given as a percent. So that's like a really big clue that you're going to need one of these formulas is if you see something is increasing or decreasing by a percentage. So the first formula is just for basic problems. The second formula is when you see the word compounded or compound, and then you see a word that has to do with how many times a year it's going to be happening. So I wrote a couple of them down. These are the more popular ones. Semi-annually means it will happen twice a year. Quarterly means it will happen 4 times a year. Monthly would be 12. Weekly would be 52. And so in the formula, that's what you would plug in for n. All of these different choices are what you would plug in for n. All right, be careful because there's another problem that will use the word compound. However, it will say compound continuously, or it might just say continuous growth. That E is a button on the calculator. That is not a variable. You're not supposed to replace that with something. And I'm realizing now that that might not even look like the letter E. But that is a lowercase e. All right, and then the last formula, that's for when you have a multiplier word. Exponential growth can be a percentage, but it's also any pattern that you're multiplying or dividing to create that pattern. So any multiplier word, like you're taking double, triple, half, quartered, this would be your basic formula. And the B is where you would plug in that multiplier number. You notice all of these formulas have the letter P in front. For every single formula, that is going to be the same type of a number. P is your initial amount. In banking, it is called the principal balance. So a life tip for you, when you have to like finance your first car or something like that, your bill will show the principal balance and it will also show the interest that you also owe. If you're going to make an extra payment, make sure your extra payment go towards the principal. That will pay it down faster. All right, so when I read each word problem, I'm basically just going to pull out the clues to help me figure out which one of these formulas I'm going to need. So question number 1 is actually 3 different scenarios, and we're going to be comparing how much money is in each account based on the percent and how many times it's compounded. So the first one, well, in all of these scenarios, we are depositing $100. So for all of these, that is going to be what we plug in for P. All right, I do have a percent in all of them. So I want to make sure I always change a percent to a decimal. The easiest way to do that is to divide by 100. I know the trick is like to move the decimal 2 places to the left, but sometimes that's like easy to lose track of or do wrong. Easiest way is to take that number and divide it by 100. So yes, this has a decimal in it, but it is a percent. So technically, even though it has a decimal, it's not the decimal value because of that percent symbol. The decimal value would be 0.023. For the second one, my decimal value 0.0225, and the third one, that decimal value would be 0.0215. All right, so make sure you take your percent and divide it by 100 before you plug that number in for R. All right, so number one, it doesn't say the word compounded at all. I just have money in an account that's going to accumulate interest. So that would be our simple formula. And I want this money to grow, so I'm going to have to make sure I use that plus sign. The minus sign would be for situations where your money is decreasing. All right, and I'm just going to plug everything in. So my principal initial amount was 100. 1 plus my rate and I just realized we don't have an amount of time, so I'm just going to make up a number real quick. We'll just pretend that all of these are over 10 years. All right, so I would raise that to the 10th power and see what I get. So I'm using the graphing calculator. If you have a Chromebook, it'd be a good idea to download the graphing calculator app. And be really careful, these are easy to make mistakes on. Just double check that everything you wrote on the paper gets typed into the calculator correctly. So we would have and 53 cents. It's money, so you should do 2 decimal places unless the problem says otherwise. All right, now the next one says compounded monthly. So that's a clue that I need a different formula than the first one. Monthly means 12 times a year. So I'm going to be plugging in 12 wherever I see n. So this is the formula that I'm using. So my principal amount is still 100. The 1 plus is a part of the formula. That's what keeps it growth. You're earning money. My rate divided by however many times a year it was being compounded, because it says monthly, that's 12. All right, we're going to pretend it's still 10 years for all 3 of these scenarios. So my exponent, just be really careful when you're typing this in. In the formula, that is the number of times each year times the number of years. It's n times t. So I'm going to have to do 12 times 10 as my exponent. So when I type this one into the calculator, 1 plus 0.000225 divided by 12 raised to the exponent of 12 times 10. If you're doing this in Desmos, you would probably want to put parentheses around the 12 times 10, or just do that first. 12 times 10 is 120, so make your exponent 120. All right, so 125.21. All right, and then the last one, my clue for which formula I'm going to use is the fact that this says the word continuously. So continuously means I'm going to be using this formula. So my principal amount, E is actually a number. It's like 2.78. My rate goes as an exponent in this formula, multiplied by time. So 100. E is this button right here. See where it says e to the x? my exponent, 0.0215 times 10. So 123.99. All right, so the better option would be to choose the first one because you make the most money, and it's not that surprising. That one does have the higher interest rate. All right, question number 2. A bacteria doubles each hour. Find the number of bacteria in 8 hours. So the fact that I see a multiplier word is my clue that I'm going to be using this formula. So in situations with bacteria, it's common that you have a single bacteria to start with. So my single bacteria, doubling means multiplying by 2 and 8 hours. So my exponent is 8. So that's really just 2 to the 8th power, which is 256. All right, the next example, a computer's value depreciates 18% each year. So the word depreciate means the same thing as decreasing. There's only one formula that really has a scenario where your money is going down, and that's the first one. But to make sure that this represents we're losing money, that needs to be a minus sign. So my initial value is $2,400. One minus my rate. I need to make sure I change to a decimal. So 18 divided by 100 is 0.18. And then my exponent, whenever they give you the number of years, just make sure you subtract the number of years to find out how many years it has been. So that's been 4 years. All right, so 2,400. 1 minus 0.18 raised to the 4th power. So $1,085.09. All right, so you will have these formulas, and we'll do some practice examples when I see you again. But like I said, make sure you go ahead and write all those formulas down. Keep them handy. I would keep that piece of paper pretty handy for the next couple of days, at least like for the rest of the unit, just so you have them all in one spot and don't have to constantly like click through Google Slides or watch a video again to get them all written down.